Writing a hypothesis, independent and dependent variables. This content will be recorded and made available in an accessible alternative format upon request. If you require captioning, transcription, or other communication services to access this content, please contact the Disability Resource Center at drc@snhu.edu or 877-591-4723, selecting option 4. The Cosby and Bates textbook gives us a good overview of the differences between a research question, a hypothesis, and a prediction. However, what you should understand from the start is that that is more of a model for helping you learn. In reality, and certainly in this class, when asked for a hypothesis, what you're expected to give is one that contains the prediction. The prediction is required for completing a study and so is typically contained within the hypothesis. Let's work through a few examples of moving from a question or idea into a testable hypothesis that contains the prediction. Let's say I want to determine if people prefer Thin Mints or Samoa Girl Scout cookies. The research question would be, what cookies do people prefer? However, that is too broad to test and does not contain a testable prediction. The textbook would suggest that you then break that down into a hypothesis question and a testable prediction. We're going to move past that and simply write a hypothesis that contains a prediction. For this class, it is strongly recommended that you use the if-then model. This structure will help you in a few different ways. We'll cover that later in this video, but for now, let's just frame it that way. So, if people taste test both Thin Mint and Samoa Girl Scout cookies, then the majority will prefer Thin Mint. Okay, let's look at that in more depth. First, it briefly describes what we're testing in the if part. We're setting up the experiment. Next, in the then part, it gives the prediction. By framing it this way, when we get to the results, we can either accept or reject the hypothesis. It is incredibly important that your hypothesis contains the prediction because you're attempting to make a claim about what all people like from a smaller group, and we do that using statistics. However, all statistics contain some degree of error in them. One way we address this possibility of an error is by making the researcher predict the finding from the start. Sort of like calling a shot in pool. You're asking them to use their expertise to predict how things will turn out, rather than just attempting something and claiming that whatever happens, that's what they meant to happen. You'll have an entire stats class to talk about that in more depth, but for now, understand that the hypothesis needs to contain a prediction to control for some degree of randomness within the result. By framing this as an if-then, you also have a bit of an advantage in determining what the independent and dependent variables are. We'll be talking about these a lot throughout the semester. An independent variable is what we're manipulating or what is difference between the groups. The dependent variable is what we're measuring as a result of our manipulation or the differences between groups. Let's look at our hypothesis again. If people taste test both Thin Mint and Samoa Girl Scout cookies, then the majority will prefer Thin Mint. So in the if part, we have people taste test both Thin Mint and Samoa Girl Scout cookies. This contains a brief description of our design, which is more than just the independent variable. However, can you see what there does describe a manipulation or difference between the groups? Here we are. Thin Mints and Samoa Girl Scout cookies. The independent variable in this hypothesis is tasting Thin Mints versus tasting Samoas. We know that because that's what's going to vary in our study. An independent variable will have at least two levels, in this case, Thin Mints versus Samoas. Next, let's look at the dependent variable. This is what we're going to measure. This will be the other thing that might be variable within the study. That is contained in the then part. What will vary is the preference for the cookie type. You might want to say that this is preference for Thin Mints, but I would suggest you keep it broader because there will be some people there that prefer Samoas, and we will also be measuring that. It's not stated but implied. On the subject of implied, let's look at another example. Let's say that we want to know if the amount of sleep people get influences how well they do on the math test. Let's make a hypothesis that contains our prediction like so. If people get more than 8 hours of sleep the night before, then they will do better on a math test. This describes what we're testing and gives a prediction on what we think will happen using the suggested format. So far, so good. Now let's look at the independent variable. Remember, that is part of the if statement. So, wait, that only contains one group. An independent variable needs at least two levels. Now what? Well, looking closely at the if statement, you can see that there is a second group that is implied. We are varying how much sleep they get, and the hypothesis specifically says more than 8 hours, so that we can infer from that that the second group is less than 8 hours, making the independent variable amount of sleep and the two levels more than 8 hours and less than 8 hours. Next, we can look at the then statement for our dependent variable. In this case, we have then they will do better on a math test. What are we measuring there? Yep, score on the math test. One final suggestion when writing a hypothesis is to keep it to one independent and one dependent variable per hypothesis. Think about this, for example. If students get more than 8 hours of sleep, study at least 6 hours, and have a full breakfast before taking the test, then they will do better on a math test and a history test. That's a lot going on. You have 3 independent variables: amount of sleep, amount of study time, and breakfast eaten. You also have 2 dependent variables, the math test and the history test. At the end of the study, you're only allowed to either accept or reject a hypothesis. Let's say that you conduct the study and at the end find that the amount of sleep and breakfast eaten makes a difference on the math test, but the amount of studying did not. Then looking at the history test, you see that all 3 variables made a difference. Well, given that we can only accept or reject and one of our predictions was wrong, we have to reject the entire thing. Unfortunate, since we were correct on all of the other predictions. However, we can instead write multiple simplified hypotheses from the start. We could give the following list instead. Now, using those same results, we can accept 5 of our hypotheses. 1 gets rejected. Later in the program, you may have reasons to get into complex hypotheses. Perhaps you see that breakfast only matters when they've also had more than 8 hours of sleep. But for so early in the program, stick to the if-then and stick to only 1 independent and 1 dependent variable per hypothesis.